Julie. Number 1. A. And tell us how you got it.
Well, I got x is 2.
Okay, how did you get x equals 2?
Because I added the 2 x's and I got 6x equals 12.
Okay, sounds like a great idea.
I isolated the x by dividing each side by 2, and then I got x equals... No, I got x 6.
Divided by 6 sounds more like it.
And then... It's actually b. Because you plug in the x, and you multiply 2 times 2, and then subtract.
Okay, so you get that x equals 2, and then you plug that in to this expression. And you get 2 times 2 minus 1 is 3. Choice B. Good. If you have a question, just stop me, otherwise I'll continue. Skylar.
Yeah.
Number 2. Guide me through your process. Okay, subtract 3. Divide both sides by 2. And then just plugged it in. Yep. Good. So there are a lot of simple SAT math problems, as you can see. It's about finding the ones that you can do, doing those, skipping the rest, coming back to them if you have time. Max, number 3. Good. A plus 2x plus 2 equals S. Okay, thank you for your honesty. What I would do is something different, actually. Remember, the SAT is a reasoning test. They're interested in your ability to reason, make logical choices. That doesn't mean there's just one way of solving any one problem. But for this particular one, because they're looking for x plus 1, and you've got x plus 1 on one side of the equation, what I would try to do is get x plus 1 by itself, instead of doing what you did. Although you could go down your path. So, how could you get x plus 1 by itself, Max? If you divide by a, it will make this term 1, and it will take this term and divide it by a, and then you'll have s over a here. So although that's an algebraically legal move, I don't think it's the most efficient one. What's another thing that you can do? How could you move this a over to the right-hand side? Subtract it. Okay, so 2 times the quantity x plus 1 equals what, Max? Good. S minus a. Now, how could you get rid of this 2? Very good. Now divide both sides by 2, and you're left with x plus 1 equals s minus a all over 2, which is choice B. Okay. So you don't always solve for x in terms of finding the most efficient route to the answer. Darian, number 4. What did you do there? Okay. We'll take a look at both sides. Notice that they look very similar. On both sides you have this first term, which looks like a plain old number.
Yeah.
And then the second term on both sides is a fraction. And in both cases, the fraction has a numerator of 2. So because they're so similar, you can just fill in the blanks. Does that help in any way? Okay. Look, equations are all about balance. So think about what you can make x equal to here and here.
Oh, so just add up the right side and see what it equals to, and then plug in numbers for the left side?
It's not necessary. Because the sides are identical in structure, then you can just apply, I guess, logic to it, for lack of a better word. So because of the identical structures, this here relates, and this here relates. You could, I guess, solve for x by combining those two terms and doing the same thing over here. But I think that is much more complicated. One other thing that just came to mind as I'm thinking of other ways to explain this to you is 5 plus 2/5 is the same thing as 5 and 2/5. So it's like x and 2x is 5 and 2/5. And hopefully you can see that the x's have to be 5s. Okay? So that's the best I can do, Darian, at this time in my life, in terms of explaining it to you.
Can I pass? I have no idea.
What's that?
Can I pass? I have no idea.
No, we're done.
Oh.
Yeah. The answer is choice E,
Oh.
5. Okay? Does anyone have a way of explaining it that you think is better than what I said? Because I would be interested, because that's the best I can do. What's that? Okay. Yeah, if I figure out another way, I'll tell you. Okay. Number 5. Melanie, what did you do here?
I divided by 5.
Okay. So you got t equals 9. And then? So you know that t times k equals 1, and you're trying to find the value of k.
Oh, so it would be.
Can you explain?
Okay. Well, if TK equals 1.
Yes.
And T equals 9.
Yes, I follow.
Then I don't know how to explain it.
Okay.
I know it's big.
So when is the only time that something times something else equals 1?
When it's itself? No.
So 2 times what equals 1?
2 times 0.
No.
Just kidding.
Try again.
Wait, what did you say? What did you
2
ask?
times what equals 1?
I don't know. I'm sorry. 2 times half.
Right?
Yes. It's reciprocal.
3 times what equals 1, Melanie?
The 1/3.
1/3. 3/4 times what equals 1, Melanie?
4/3.
You get it?
There we go. I got it.
What is the x in all of these cases?
1.
No.
The reciprocal.
The reciprocal of the first factor.
Yes.
Okay?
That's why it's 1/9.
So anything times its reciprocal, Melanie, is?
1.
There you go. Therefore, if you have the first number,
Nailed it.
t, then k is going to be the reciprocal. Okay? See, it's a reasoning test. So, in other words, k is 1 over t, or just the flipped version. So if t is 9, then k has to be 1/9 in order for the product to be 1. Good. Thank you for your cooperation there, Melanie. Brooke, number 6.
Okay, so I use the x minus y equals 8, and then I plugged in 3 for like the first part of y, and then I put in parentheses 2 because it's 3z and z is 2.
Nice.
I got x minus 3 times 2 is 8.
Good. So this is just substitution. You know that x minus y equals 8. You know that y equals 3z. So anywhere you see y, you can replace it with 3z. Then we also know that z equals 2. So everywhere you see z, you can replace it with 2. Then it's easy. What number minus 6 equals 8? 14. Choice E. Okay? Someone tell me how much time I have left in the period? Thank you. Jackie, number 7.
I distribute the 3.
Okay. What's another thing that you could do?
We divide it.
You can divide by 3. So I'm going to do that just so people who are just used to distributing all the time can see an alternative. So what do you get, Jackie, if you do that? Yep. And then n equals 10. Good. Okay, Skylar, number 8. Okay. So he distributes. That's one way to do it. Subtract 65. 6,500 equals 65 times the number. Yep. So it's got to be 100. 65 times what equals 6,500? 100. Good. And Vicky, number 9. Yeah, that's fine. There's something that you can do to do this in a quicker manner. You're trying to get to x minus 5, and you... Excellent. Yeah, see? One step. So we're teaching you how to be more efficient. Or you're learning to be. Okay. 10. Melanie. If a times k equals a for all values of a, then what is the value of k?
Alright, well, I got stuck on this one.
Okay. I appreciate your attitude. So check it out. When we multiply times k, it's doing nothing. What is the only number that when you multiply something by it does nothing?
1.
Yeah, right? So choice D. I think that's called the multiplicative identity. 1. No, the multiplicative inverse is the reciprocal. Okay? Next, Scott, number 11, please.
So you distribute the A, you get AX plus AY equals 45.
Okay, distribute.
Then you can take away the AX and replace it with 15.
Good, AX is 15.
And then you subtract 15 and get AY equals 30.
You get negative AY.
Oh, it's negative.
Oh, no. I retract my statement completely. You get AY equals 30. 30. Good. Okay. Next, Max, number 12.
I started by dividing both sides by 100.
Great idea.
So I got 67 equals 6k plus 7.
Mm-hmm.
And I subtract 7 from both sides and divide by 6.
Yeah, you can think about this logically too. 67 is 6 times what plus 7?
And
Yeah, you can use like your understanding of place value. You know, for centuries, the Europeans were not using this system. What were they using? Shout it out. Okay. What was a major power in Europe like 2,000 years ago? Europe, Southern Europe, North Africa, Middle East. Think somebody might have said it? Rome. Very good. Yes, Roman numerals. Okay, for centuries, even after the fall of the Roman Empire, the Europeans were working with Roman numerals. They were doing math in Roman numerals. Okay? Is that a question? Yes.
Why are Roman numerals still used at all?
I think because they give this air of sophistication and importance. That's my guess, like to the Super Bowl. Okay, the reason for saying that is finally the Europeans realized that there's a much better system. It originated in India. It worked its way through the Middle East. The Islamic mathematicians figured it out first. Then it eventually moved its way to North Africa because the Islamic Empire was enormous. Then some Europeans were in North Africa. They noticed that the traders there were using this system. They said, this looks much better than Roman numerals. And this is like the 12th century. So the fall of the Roman Empire was what century? Western Roman Empire was what century? What's that? The fall of the Western Roman Empire was what century?
Is it BC?
It's AD or CE. Later than 200.
300.
Later than 300. 400. It's 476. So 5th century. It's not until the 13th century that Europeans start using Hindu-Arabic numerals, which is what we use today. So you're talking like 700 years, 7 centuries of using Roman numerals after the fall of the Western Roman Empire. Fortunately, we have them today because I think that they're much easier to work with. So, you take this for granted most likely, that you can interpret this. But, back in like the 11th century in Europe, I don't think anyone would know how to interpret this. It wasn't even how we were writing numbers back then. They wouldn't have seen these symbols. So, what this means is 6 times what? Shout it out. 10. Plus 7 times what? 1. Okay? The numbers have values based on where they stand in the sequence. It's called the place value system. So if you look at the right-hand side, it's basically mimicking this. Okay? 6 times 10. So K equals 10. So do your best to use your reasoning ability as opposed to just straight up algebraic solution. But if that's all you've got when you're taking the test, then go with what you've got. We do the best that we can in any given moment. Okay. Next, Alexandra. Number 13. Okay. Well, we have to find 3x over 2y. Look, we already have x over y. How could you transform that to become 3x over 2y? Flip it? I don't think we should flip it because we want x on the top and y on the bottom. I wouldn't cross multiply, although you probably could get to the answer. I think there's more efficient. So what could you multiply x over y by to make it in? What's that? So answer my question. What can you multiply x over y by to get to 3x over 2y? Yeah. What can you multiply x over y by to get to 3x over 2y? 3 over 2. Does that make sense? Yeah. Okay. But this is an algebraic equation. I can't just multiply one side by an... There you go. And Alexander, what happens on the right-hand side when you do that? What's 2/3 times 3/2? You don't even need a calculator if you understand the relationship between 2/3 and 3/2. What's that? Okay, well, what's the value? And why? There you go! Learning has occurred! Okay? 2/3 times 3/2, in other words, 2/3 times its reciprocal must be 1. Okay? 55, right? Good. Next random victim, helper. Darian. Number 14.
Okay. Minus 3x.
Okay.
So it's 9 equals 2x plus 1.
9 equals 2x plus 1.
And minus 1.
Minus 1.
8 equals 2x.
8 equals 2x.
Then divided by 2, and x equals 4.
Very good. As I was saying before, you will encounter quite a few SAT math problems that are simple for you. There's nothing wrong with that. Anthony, number 15. Happy birthday,
Thank you.
bro.
Okay, so I have to do that, I'm sorry.
I'll allow it.
I think we're gonna have to multiply the reciprocal of, right?
Multiply by the reciprocal.
Oh, no, we're gonna cross multiply.
I like cross multiplying better.
Okay, so
37x equals 39x minus
um 78,
78. Good.
and then we're gonna subtract 39x.
Okay, we can do that. Subtract 39x.
So we're gonna get -3.
Let's try negative 2.
Okay.
X.
Equals -78.
Negative 78.
Divide by -2.
Divide by negative 2.
And then 39. Yeah.
X equals 39. Go ahead. Question or stretching? Okay.